Oh, hello, friends! I'm Jen Foxbot, and welcome to a new recurring series that I'm gonna start called Math Mondays. Woo! So, based on the name, you probably guessed that I'll be doing math problems on Mondays. Yeah, fun! Math is awesome! So every Monday, you can tune in to Instagram or YouTube, and hopefully, as long as my schedule doesn't get too crazy, I'll have a new video of me showing you how to do a different type of math problem. To get started, I pulled out one of my old physics textbooks and picked a problem that I thought was really interesting. And for future episodes, I would like to open the floor to y'all. So if there are math problems that you're stuck on or interested in or just want to learn more about, please feel free to send them to me. I won't do all of your homework for you though, and most of the time you have more than one problem, so you will get one, which is helpful. But yeah, you are smart and you can definitely figure out your math homework on your own, / by asking people around you as well. Alright, so let's get started, yay! So I wanted to choose a problem in the early part of my introductory physics textbook, which is this one, Physics with Modern Physics. Fun! So this is from chapter 2. This is a super old version, but just in case you're curious, chapter 2, problem number 8b, because 8a is boring, it's just converting the speed of light into something different. So what we're going to do is part B, and here is the problem. Electrical signals in wires travel at about half the speed of light. What is the maximum possible separation between a computer's central processing unit, or CPU, and its memory if the central processor is able to get a signal to memory requesting data and have the data return all in 8 nanoseconds. So word problems are super fun because you have to pull out the information that you need to be able to solve the problem that they're asking. I like this because it's a real problem. People have to design computers and think about these things. Yeah, so here we go. So the first key piece of information is that the speed of light travels at about the speed of the electrical signal travels at about half the speed of light. So that means that the speed that we're talking about of the thing, which is just charges moving through a wire, is 1/2 c. And that is 1/2 times 3 times 10 to the 8th meters per second, which equals 1.5 times 10 to the 8th meters per second. So that's the first key piece of information that we need. And the second piece that we're told is that the time that it takes to go to the main memory unit and back is 8 nanoseconds. So that means if we want to design our system so that the time of flight is 8 nanoseconds, we actually need to design our system so that our electrical signal is traveling in half that amount of time. Another way to put it is, so your computer is here, the signal goes here, but then it comes back. So it's actually traveling that distance, x, twice. I'm going to erase that. So t is 1/2 times 8 nanoseconds, and nano is just a prefix, which means 10 to the -9th. And so this is going to be 4 times 10 to the -9th seconds. Okay, and now we pull in our handy-dandy equation. I'm going to write over here to keep it out of the way. V equals the change in distance over the change in time. And so in this case, we're looking for the change in distance. We know the speed, and we know the change in time. And so we can say, okay, so delta x, let's see if you can see that. Yeah, okay. Delta x equals v times delta t. And since we know what we're talking about, we can get rid of these deltas, because I like to be lazy sometimes. That's okay. So to solve for x, we just multiply the speed of, 1/2 the speed of light, 1.5 times 10 to the 8th, oh my chalk's getting all messy, times 10 to the 8th meters per second, and I'm going to run out of space on that line, so I'm going to write it down below. 4 times 10 to the negative 9th seconds. And right away we see the seconds will cancel, and our units will be meters, which is good because meters is a distance, a unit of distance. So I'm going to plug this into my handy dandy calculator because as much as I love math, I don't like doing unnecessary mental math. And also we have calculators that are a little bit better at it than us, so might as well use the tools that we've got. So I plug this in, 1.5 times 10 to the 8th times 4 10 to the negative 9th. So I'll show you that, and hopefully it's not too blurry. All right. And then I hit enter. Ooh! All right, so X, I can give you some time if you want to do this on your own too. All right, so hopefully what you got also agrees with what I got. I got X equals 0.6 meters. Ooh, fun! Personally, I really like the metric system because I think it makes more sense than the imperial system. Is that what it's called in the US? The SI system? Whatever. The feet, miles, weird stuff that we use over here in the US. So you are welcome to take this number and plug it into Google. If you're like, hey, convert 0.6 meters into feet, it'll just send it back right like that because Google has handy tools like that. Yeah, so then us fancy mathematicians can go back to our computer designers and say, excuse me, I have figured out your problem. You need to design the computer so that there is a minimum separation between the central processing unit and the memory unit that is less than 0.6 meters. And your designer will probably laugh and be like, oh, that's great. I can definitely do that. Because that's actually not super far. That's like a little over a foot. Or yeah, that is pretty far. So it should be fairly easy to, these days to design a computer that is smaller than that. Although it is kind of funny because I bet when this textbook was written, that was actually pretty small for a computer because computers used to be huge. Good times. Okay, so I hope that you found that informative. Please let me know if you have any questions or if any of this was unclear. If you do end up converting this, feel free to leave it in the comments so that other folks can see what that distance is in different units. Yeah, and then of course, like I said earlier, please send me your math problems or things that you would like me to calculate on the board. Yeah. All right. So thank you for watching, and I'll see you next time. Bye.